Okay, so this last section is true and false. This section, really, I think that the easiest way to get through it, if you don't really want to do very much algebra, is just let A equal 2, B equal 3, and C equal 4. And then work with one side of the equation, get a number, work with the other side of the equation. If it's the same number, then it's true. If it's not the same number, then it's false. I didn't make any of these terribly complicated. I am going to go ahead and do the algebra on most of them, and if I have to rely on those numbers, I can. But those numbers are really, really helpful. So for 23, this is a distributive property problem. Since you have that plus in the middle, that makes this distributive property. So this is CA plus CB. That is equal to the other side of the equation, so 23 is true. 24, this one is not true. So this is not true. We can't break up under a radical like that and kind of take the minus out of the radical. Again, if you want to rely on those numbers, square root of 2 minus 3, that would be square root of negative 1. Over here, that would be square root of 2 minus square root of 3. Not the same as negative 1. So that is false. If you would even, for this one, want to pick numbers that do have perfect squares, that would be a nice way to show that one for yourself. So pick like 4 and 9 as your A and your B to kind of convince yourself that that one does not work. 1 over A plus A. So if I was going to do the algebra on this one, I'd do 1 over A plus, I need a common denominator. This is A over 1, so I need to multiply the bottom and the top by A. So that would be A times A is A squared over A. The way that would combine over the common denominator of A would be 1 plus A squared. That is not equal to 1. Kind of when in doubt, false on these. All right. 4 over A plus 8 over B equals 12 over A plus B. That would not work for every value of B. That would not work for any value of A and B that I can think of, actually. Here, we don't have a common denominator. So we would need to multiply this guy by B over B, and this guy by A over A. So what we would actually get is 4B plus 8A over AB. Not the same as 12 over A plus B. Here's a quick exponent rules problem. Hey, cube root is the same as to the 1/3. Absolutely. Right? The bottom is your root. The top is your exponent. Right? A to the 2 divided by 3 is the same as the A to the 2nd over A to the 3rd. This problem, remember, I'm going to work with this side here. When we have the same base and we're dividing, we subtract our exponents. So this side is actually the same as A to the negative 1, or 1 over A to the 1st. The left side of this equation, 3 would be your root, 2 would be your exponent, so it'd be cube root of A squared. So that one also false. 29, one of my faves. We can't distribute in over that negative. You could distribute that squared in if you had A times B. Absolutely. But A minus B is this. A minus B times itself, which of course is going to have a middle term. And negative B times negative B is positive B squared. So that guy, totally false. 30 is going to take a little algebra here. So for number 30, we can absolutely do this division. We can break this guy up. But if we're going to break it up, we need to break it up into 2 fractions. So it would be 10x over 5 plus 1 over 5. So that would be 2x is the first term, but the second term would be 1/5, not 1. So that guy is false as well. Very last problem. 8 to the negative second equals negative a squared. All right, well, 8 to the negative second, that guy really is 1 over a squared, not negative a squared. So, again, if plugging in numbers helps you, I like 2, 3, and 4. They keep you out of trouble that 1 and 0 can get you in. But you can also, knowing the algebra rules is really the intent here. But if seeing a couple numbers on some of the tougher problems for you, or the tougher little true and false problems, if the numbers help you, then use them. All right, I hope these videos were helpful. Go back and redo problems. If you didn't get them right, go back and practice with the problems that are in the modules, within the modules, and come back and cover these up and try them again. It doesn't really matter that you've seen them before. That repetition is really powerful. All right, I look forward to meeting you in August.